All right, everybody, welcome back with another episode of Sharp Education. Today, I'm really excited for what we have in store. This is going to be our first dive into a machine learning framework with our trading strategy. Right now, we've gotten the foundation of what computers are doing when they're learning from data, and that's good, that's a start, but machine learning involves out of sample testing, which is what we're going to be looking at today. And the reason we've kind of gone really deep into, if you look at this study, we've gone really deep into looking at the optimal shift to find the perfect area under the curve score, is to explain what happens when we overfit to data. And I know I kind of set you up for a trap where it's like, oh, this looks really cool, and if based on this data, all I should do is just hold for 96 periods, and it makes intuitive sense. But what we're going to be doing today is we're going to be running this same test on two data sets. And that will show you what overfitting is and why it's so hard to avoid and what machine learning is trying to overcome when you conduct it. So now I'm just throwing a bunch of terms at you. Train, test, split, out of sample testing, overfitting. Oh my gosh, what is all that? We're going to find out. And, well, I hope we find out in this episode, but it might have to be broken into two. So we're going to make a new file to set up our data into breaking it into two different sections. We'll call it train test.ipynb. Great. And there's going to be a key difference in our data acquisition step. So let's go back to reg changes. I'm going to put these side by side because the files are going to look very similar, but there's going to be a key difference. So let's see. Let's import all of this. And I'm also going to be using sklearn's train test split. No, I'm not. That'll be a later episode. Today we're going to be doing it manually so we understand exactly what's going on. You're not confused by any of the packages we install. Yep, we're going to take all of our global variables because we're again going to be using all of this information in our study. We're going to get data and plot it the same way we always do. Control C, Control V. Perfect. We need to define everything, including adding the target. So we have RSI, Bollinger Bands, Money Flow Index, MACD. That's 4 technical indicators, right? Yes. Perfect. And from here, this is where things are going to start getting funky. Now, I'm going to make a new function, and it's going to be called train test split. Now, in our regression output, we have this line here that shuffles all of our data. That means once we've added our target variable, before we conduct a regression analysis, we're shuffling the order of all the rows. So instead of going 1, 2, 3, 4, 5, if you have 8,000 rows, it could start off with 7,814 and go to 3 and go to 2,506, whatever. So we are keeping this random principle in our data. We want to make sure that stays, because if we don't, then that leads to autocorrelation, and even though we're doing a train test split, that problem still exists. So what I'm going to do is, instead of generate this regression output, I'm going to do define train test split. Test split. It'll just be the name of this function in the data frame. And I want the argument for this function to be what percentage of data we want our training size to be. So we'll do train size equals, and then 0.7. So it'll be 70% of the data we have available will be the training size, and the 30% will be the out of sample. So what that means is we're going to be applying our generate regression output model to our training data. And then once we have our weights and biases determined, which are not the right terms, but once the model understands the information in the training set, we're going to be applying those numbers to the test set to see if it keeps going. And we'll learn a lot in whether or not it does. Train size is 0.7. And I think that's all we need for now. So when we do this train test split, the subset is going to be, well, data frame is going to be now data frame.sample sample frac equals 1 fractal, and we're going to reset the index, drop it. That just makes alignment easier when we drop the index, because you don't want your index to start with a weird number. It's always better to have it start at 0, 1, 2, 3, 4, 5, and so on. That might be unnecessary information. Now that we have our data frame all shuffled, what we want to do is get the row in which we have split. So what's the row we want to split is going to equal len data frame times 0.7. And we want to round this, or we can say as type.int. As type int. I think that should work. So when we return this, I'm going to print split. Perfect. So let's run everything up until train test split. Connect the RSI. Data frame equals add target. And data frame equals train test split of that data frame. Return the data frame. Frame equals main. Select the environment. And I'm going to put this back here for now. Something's wrong. Got to install the packages. Did not add the shift. We're not doing that loop for now, so shift is just going to be what we set it as manually. Shift equals 1. Okay, so now the split is just going to be an integer of the length of the data frame multiplied by 0.7. So our training set is going to have 1,330 rows, and let's just print the length of the data frame so we know what that is. So data frame equals, I'll print len data frame. I said data frame equals main, right? I did. Turn the data frame. Here it is. So when we run everything now, okay, so the data frame originally has 1,901 rows, because I think we're working with minutely data. Yes. But the training data is only going to be 1,330 of those rows. So we're going to be training the model on these 1,330 rows, and the patterns that the machine can identify in this set, we're going to try and extend onto the remaining, what is it, 700 rows or so? No, 600 rows or so. Perfect. Now, what we want to do here is keep building on this train and test split. So train is going to be data frame dot iloc, and it's going to be all of the rows up until split and all of the columns, and then test is going to equal data frame dot iloc split onwards. So whatever that number is, which is 1,330, we're taking the first 1,330 rows for training, and we're taking the last remaining rows for test. And we also want all of the columns for test. So let's return the data frame, train, and test. Now, the reason this works is because we shuffled beforehand. If we didn't do this shuffle, the data would still be in a linear format. So we would be learning from past data, and then we would be testing on future data. And theoretically, that's okay when you're working with time series data, but it's not what I want to do. Because of the variables we're working with, I'm going to leave it at that. I think it's very difficult for me to understand why I'm doing this shuffle. So for me to explain. So we're doing this. We have shuffled data. We're splitting it into 70 and 30% of the data size. We can also do 0.6, or some people even do 0.8. But 0.7 is my favorite. Doesn't really matter what it is. It does matter. We're leaving it at 0.7. Okay, and now that we have train and test split done here, we can do train and test, and then return that at the end of our main function. Test, train, test. Perfect. So data frame, train, and test are going to equal main. So once we have all of this information provided, let's take a look at our training data set. It's 1,330 rows with all of our information. And test is going to be 571 rows with all of our information. Great. Okay, and all of this should look pretty familiar. This is the data we've been working with for the entire series, where you take in your technical indicator information, and you can still see the negative flow, positive flow used to build the MFI, the Bollinger Bands, and every aspect of them, the simple moving average, the standard deviation, upper band, lower band, and then the actual Bollinger Bands. It goes on and on and on and on and on. We have a lot of data, 29 columns, but we're only working with the columns specified in this strategy variable. So we're only regressing on what is selected there. But this is the important part today, and it's where we're going to end this particular episode. I'm excited for the next one. We have split our data into two different parts, and now when we generate our regression output, we're going to be building it only on this training information. The test information, we're going to leave it alone, and that's going to be treated as out-of-sample data, or data that the machine cannot see, imagining it's future data. So what's going to happen once we're done training this model. And this is the current data that we have available for us, or we've restricted ourselves to. So we can look at other data sets. This is minutely Tesla data. Let's take a look at S&P 500 daily data, which is the most abundant in Yahoo Finance. So SPY, 1 day, run everything. You again don't need these plots that show up. It's mostly just for informative, exploratory purposes. Now, again, we have much more information in the training set than we do in the test set. 70% of our data will be training. So we have 5,688 rows to learn from. And then once our model has learned from this training set, we can test it on the test set. And if the results from our training and test set are similar, then that means we have not overfit. And this is a big struggle. A lot of trading strategies, again, especially if you don't know how to code, keep in mind, what we're comparing ourselves to are people scrolling back on their monitor and then identifying a pattern with their eyes and finding something that sort of worked. And even if you're the best at that in the world, even if you did that for like a week straight without sleeping, you would still be overfitting to that ticker. And then there would be you still wouldn't know what would happen in the future. That's how the stock market works. It's fascinating. And you can tell it's interesting to me. But it would never work. So you need to have this out-of-sample data in order to verify that what you're doing will work going forward. If you don't have it, you're just finding cool patterns that existed in the past, but the stock market doesn't work that way. And this is where we start really understanding why it's so hard to win in the stock market. This training set, you're going to notice the machine is always able to identify some sort of pattern there. Easy. Like, wow, it's obvious that, if you look at our regression outputs even, with our regression changes, you'll notice like, oh, we're getting further away from the curve and we didn't even have to do much modification at all. Just if we just optimize the shift, we can find some pretty good separation. The machine's really good at identifying patterns in past data. The issue is future data won't be the same. Now, if we can come up with similar separation on training data, which we will, and then apply this to test data, you'll notice that it's going to look really bad because the optimal shift won't be the same on the training and test sets. I'm getting ahead of myself. Sorry. In the next episodes, we'll learn exactly why or how overfitting looks, what it looks like, and how we can maybe mitigate it will come in future episodes. But this is it. This is the train and test set. You can also adjust this this number we have to split it. I set it to be 0.7. But we're going to actually add a global variable before we go. Even if we do 0.8, which some people like to do, and we run everything, you'll just see the data frames we have to work with now are 6,500 rows and 1,626. So more train, less test, just with a different split. And that's it. That's how you split your data frame into training and test. Going forward, we will actually use this to come up with useful information. So, thanks for sticking around. Congratulations on getting a little bit smarter about how machine learning works, why you need to understand this in order to have any sort of an edge in the stock market. And that's it. Until next time, stay sharp.